on to the determination of the concentration of antioxidants in commercial beverages using the Foley-Seal-Kelto microspectrophotometric method. For this presentation, I will first establish what free radicals and antioxidants are, then move on to the Foley-Seal-Kelto assay and our procedure, followed by our results and conclusions, as well as acknowledgements and references. To start off, free radicals are unstable species that are missing an electron in their outermost orbital, which makes them highly unstable and chemically reactive. As a result, it can oxidize our proteins and cell membranes, as well as denature our DNA, which can lead to diseases such as aging and cancer. This is a condition known as oxidative stress. To combat oxidative stress, our biological systems have put in place antioxidants, which are substances that can provide a free electron to terminate free radical reactions before oxidative stress occurs. They are naturally found in vitamins, plants, vegetables, as well as many beverages such as teas, juices, and coffees. The Foley-Seal-Kelto reagent is a mixture of phosphomolybdate and phosphotungstate that acts as a free radical quencher, forming a blue complex that can be measured through visible spectrophotometry. For this assay, gallic acid is used as a standard measurement as well as in the winery business. This method also uses micro quantities, leading to less waste products as compared to other methods. For the procedure, 5 different solutions at 5 different concentrations of gallic acid were made. Then, 80 microliters from each solution were extracted and mixed with 1.6 milliliters of distilled water and 160 microliters of the reagents. After waiting around 5 minutes, we then added 480 microliters of the sodium carbonate solution because the reaction can only take place under basic conditions. And then after waiting 2 hours, we measured the absorbance values at 600.0 nanometers using spectrophotometry. For the preparation of the sodium carbonate solution, we mixed 80 milliliters of distilled water with 20 grams of sodium carbonate, which were then heated, stirred, and filtered. The total concentration of the sodium carbonate solution is approximately 2.36 molar. For the teas and instant coffees, we weighed 0.5 grams of the tea leaves or powder mixed with 50 milliliters of distilled water and boiled for 10 minutes in reflux. Then they were diluted and filtered, and the same procedure for the gallic acid was followed. For the juices, 2 milliliters of the beverage were diluted with 4 milliliters of distilled water, and the same procedure for the gallic acid sample were followed. Similarly, for the coffee drinks, 1 milliliter of the beverage were diluted with 8 milliliters of distilled water, and the same procedure for the gallic acid was followed. For the absorbance values, we utilized Beer-Lambert's law, where A is equal to epsilon times L times C. A is the absorbance values, epsilon is the molar absorptive coefficient, L is the path length, which is usually 1 centimeter, and C is the concentration. By utilizing Beer-Lambert's law, we were able to create a standard calibration curve for the gallic acid. We first plotted the absorbance values of various concentrations with a line of best fit. Then, for the absorbance values that we measured for each beverage, we extrapolated the concentration of antioxidants in milligrams per liter from the line of best fit. For our results, as you can see here, Trader Joe's Jasmine Tea has the highest concentration of antioxidants, followed by Ritual's English Black Tea and America's Choice Earl Grey. For the instant coffees, there does not seem to be a difference between the brands Nescafé and Folgers, as well as caffeinated or decaffeinated. However, for the bottled coffee drinks, Starbucks Milk and Honey seems to contain the highest level of concentration as compared to black coffee and Frappe. For the juices, Delsa's Farms Prune Juice seems to contain the highest level of antioxidants as compared to the rest. I would like to gratefully acknowledge the support from the CUNY Research Scholars Program, Queensborough Community College, Tina Van, Lakshita Puri, Sophia Howe, and Dr. Paris Sobranos. These are my references. Any questions?